In this simulation, we want to figure out if we can form a bond between these two atoms. So I'm going to hit play, and we're going to observe the behavior of the atoms here on the left side, and we're also going to take a look at the energies on the graph on the right side. So I'm going to press play. First, let's look at what happens to the atom on the left side. So you notice that it kind of collided similar to the what do you call them? Like the billiard balls on the video that you watched earlier. I'm going to hit reset, and I want to watch that one more time. Go here. Click play. So they collide, and they bounce away from each other. So what's interesting, though, is that we did form a bond for a split second. If you watch very closely, you'll see a dark bar appear between the two atoms. Watch again as we do that. That represents a bond that formed. Very short-lived. Eventually, the collision causes them to go away from each other, and a bond doesn't form. Now, as far as the energies go, let's take a look a little bit closer at what's happening. This part of the graph here represents zero potential energy. The atoms are not interacting with each other. However, when we do get close enough that the attractive and repulsive forces are balanced, we do create that bond for a little bit. But as our potential energy lowers, look what happens to the kinetic energy. The kinetic energy gets extremely high, which we see as a lot of movement between these atoms. Now it gets to the point where it's so high that we eventually break that little bond that we formed. We no longer are bonded to each other, and the atoms are going to move away from each other, no longer interact, and then we have a flat line there. We did. So let's watch that one more time now that we've kind of figured some things out. Oh, let me hit reset. And then we're going to hit play, okay? So short-lived bond, kinetic energy gets too high, too much movement, they pull away from each other, the bond breaks. That's the end.